In this section, we're going to talk about systems of inequalities. This is section 5.4 in your college algebra textbook. Systems of inequalities is something that we've actually studied before, but again, we're going to talk about nonlinear inequalities instead of just focusing on linear inequalities. Again, in your previous mathematical studies, you've looked at systems of inequalities that involve just lines, basically. All right, so what I want to do is I want to review how we graph a single inequality that involves a curve. And these are the procedures that we go through. All right, the first thing we do is we graph the corresponding equation that relates to that associated inequality. One thing that you have to remember when you graph those associated equations is whether you're going to use a solid curve or a dashed curve. We use a solid curve for a less than or equal to and a greater than or equal to sign, and we use the dashed curve for a less than or a greater than sign. And basically what that is that's very similar to when you plot, when you have an equality. For instance, if I had something like x is less than 5, of course, if I were to graph that on a number line, you put 5 on there, and you can zoom in, right? Whether you use an open point or a closed point, right? When there is no equal sign, you use an open point. And if that was a less than or equal to, you would use a closed point. And so this is what we do when we're graphing in the XY plane. Instead of thinking open and closed, we're going to think solid or dashed, all right? And once we have our curve graph, the next thing we're going to do is we're going to choose a test point, and we're going to use the test point method so that we can determine where we're going to shade. Remember, whenever we graph represents all the ordered pairs that are solutions. When we have inequalities, there's an infinite number of ordered pairs that may not only just lie on the curve, it may lie anywhere on either side of the curve. So we're going to either be shaving above the curve or below the curve, to the right of the curve or to the left of the curve, right? And so let's look at an example with just one single inequality. And this one says graph the inequality y is greater than x squared minus 3. And so what I'm going to do, one of the first things that I like to do is to determine whether the line that I'm going to graph or the curve that I'm going to graph is going to be solid or dashed. That's one thing that's very, very easy to forget. And so I always try to remind myself to write that down first. And so since I have a greater than, right, no equality there, I'm going to remind myself that this is going to be dashed when I graph it, okay? And then I'm going to graph the corresponding equation, right? Had that been an equal sign, I would be graphing y equals x squared minus 3. Now, from our study of our library of functions, I know that this is a parabola that has been shifted down 3 units, all right? Excuse me, that's the x squared minus 3, right? So I'm going to just graph that using transformations. I'm not going to go through all the transformation process, but I know that my vertex is going to be at the point 0, negative 3. And it's going to follow the same behavior as f of x equals x squared, right? So I'm going to get a point like that right here. And I can graph many other points that are on that graph, right? But I'm going to just use these two. And one thing that I've got to remember is that I've got to dash this in. And so this needs to be a dash, and I was drawing a solid line. But we're going to dash that in as we draw. And so I have the graph that represents the associated equation for this inequality here. And now what I got to do is I've got to take care of the inequality part, the greater than, all right? And so I'm going to choose a test point. And when I say test point, I can choose any point that is not on that curve. And I'm going to be careful here because we've done a quick sketch of that curve. I want to make sure that the point that I choose has there's no way possible that it can be on the curve. And so I'm going to choose the point 0, 0. And so what I'm going to do is I'm going to plug in 0 for x. I'm going to plug in 0 for y. This is like inside our parabola here. And I'm going to substitute it back into the original inequality that I started with. So put 0 in for x and y. We get this right here. And I get that 0 is greater than negative 3. And now what I want to do is I want to determine whether this is a true statement or a false statement. And that would be a true statement. And since 0, 0 is on the inside of the function, that means that my solution set lies inside of that parabola there, right? And so since 0, 0 is on this side, I'm going to always shade on the side where 0, 0 is. Now, had I gotten a false statement, 0 is, less than -3, then I would have shaded on the outside instead of the inside. But since I got true there and 0, 0 was on that side where I got true, I shaded on that region there. All right. And so that's a review of how we graph an inequality that involves something that is nonlinear. Now we're going to come to determine how we can graph when we have a system of inequalities. Okay. And it's basically a very similar process, right? This says graphing systems of linear inequalities in two variables is similar to graphing inequalities. The only difference is that we're going to have to graph more than one inequality. Also, we're going to have to choose more than one test point. And so one of the things you want to remember is that our solution set is going to be the intersection of the shaded regions. And so what we're going to do is we're going to go through the process of graphing these, but I'm going to wait till the end in order for me to graph so that I can make sure that my graph isn't so messy so that I won't mess up while I'm graphing. Let's look at some examples. This is our first example. It says graph the system of inequalities. X squared plus y squared is less than or equal to 25, and 3x minus 4y is greater than 0. All right, if I look at that first one, x squared plus y squared is less than or equal to 25. All right, what I'm going to do is I'm going to tell myself that this has got to be a solid graph when I, graph the curve here. And the associated equation that I'm going to use here is x squared plus y squared equals 25, right? And so back in the day when we were dealing with equalities and we wanted to graph something like this, we would notice that this is a circle. Its center is at the origin, and its radius is always sitting on the right-hand side squared is 5, right? And so what I'm going to do is I'm going to draw me a circle on my graph with a center 0, 0 and a radius of 5. And just as a review, remember equations of circles all come in the form x minus h quantity squared plus y minus k quantity squared equals r squared, where the center is hk and the radius is r. And so in our example, we don't have anything subtracted from the x here. That's why our x coordinate of our center is 0. And here we don't have anything subtracted from the y, and that's why our y coordinate to our center is 0. And of course here we have our radius squared, and I square 5 to get 25, and so our radius is 5. And so we're going to come over here and we're going to graph. And so we're going to put our center, which is at the origin. And since our radius is 5, I know that if I go to the right 5 units, if I go up 5 units from the center, to the left 5 units from the center, and if I go down 5 units from the center, I would get points that are on my circle. So I'm going to try to draw a circle as best as I can. All right, and notice that I did draw it solid, so I have a solid circle here. All right, now I'm going to choose a test point. All right, and my test point is going to be any point that that circle does not pass through. All right, and so I'm going to choose 0, 0. So I'm going to use the test point 0, 0. I'm going to plug 0, 0 into my original inequality, which was once again x squared plus y squared is less than or equal to 25. You can probably look at that and tell, but 0 squared plus 0 squared is less than or equal to 25. That's 0 is less than or equal to 25, which is true. All right, and so since 0, 0 was inside of the circle, that means that my solution set lies on the inside of my circle. Now what I'm going to do here, if you notice, I put an arrow there just to remind myself that I'm going to shade inside of this circle instead of shading outside of the circle. And I don't want to shade right now because I have to do this other inequality as well, which we hadn't even talked about yet. And so if I start to shade right now, my graph is going to get a little too messy, and so that's why I'm going to do that. Use these arrows here. But that's just reminding me I'm going to shade inside of that circle there. Now we're going to go to the other inequality, which was 3x minus 4y is greater than 0. I'm going to tell myself that when I graph this, it's going to be dashed. Okay, I got to remember that. And once again, it's very easy to forget. But what I want to do is I'm going to graph the equation that's related to that inequality, which is 3x minus 4y equals 0. That represents an equation of a line. And so I'm going to use my slope and my y-intercept to graph that line. First thing I'm going to do is I'm going to subtract 3x from both sides. I get a negative 4y equals a negative 3x. And then I'm going to divide both sides by a negative 4. And that'll give me that y equals 3/4 x. The slope of that line is 3/4, and the y-intercept is 0. All right, and so I'm going to start at 0, and I'm going to go up 3 units and to the right 4 units, and I have another point that's on that line. So let's go to our graph and do that. All right, again, start at the origin, which was 0, 0. And I'm going to go plot my point there. And I'm going to go up 3 and to the right 4. And I'm going to draw a dashed line that passes through those 2 points. And notice I can use my slope. I can go down 3 and to the left 4, to the left 4, and notice that that is going to be on that same line as well. Okay. And now what I'm going to do is I'm going to use a test point once again. All right. Now I've used the point 0, 0 for my circle. All right. The perimeter of my circle, the circumference, the outside of my circle did not go through the point 0, 0, so I was okay with using that point. But if you notice here, this line does pass through the point 0, 0. Okay, and so since the line passes through the point 0, 0, I cannot use that as a test point, because if I did, I wouldn't know which side of my line to shade on. And so I'm going to use a point that's not on my line. Let's say I use the point 1, 0. 1, 0 is on the right here. If you want to say on the right side or the bottom of your line, you can. All right, but I'm going to use that as my test point. And so I'm going to come down here, and I'm going to plug in the point 1, 0. Into that inequality. All right, and so I get 3 times 1 minus 4 times 0 is greater than 0. Okay, and the rest is for me to simplify to see if I get a true or false statement. Well, that'll be a 3 minus 0, which is 3, is greater than 0, which is true. And so since I got true, I would shade on that side of the line. All right, and so since 1, 0 is on the bottom, if you want to say bottom, or to the right, then I'm going to have to shade below that line. Okay, and so my shaded region is kind of where my arrows meet. I have to be both inside of that circle and below that line. All right, and to satisfy both of them, I would have this region right here shaded. All right, and so the points that are on this circle, as well as the points that are shaded, would be the points that are the solutions to this system of inequalities. It would satisfy not only one, but both of these inequalities here. All right, and so we're going to look at one more example of this just to make sure that we've got it. Let's look at the next example. In this example, we have x minus 1 quantity squared plus y plus 2 quantity squared is less than or equal to 9, and y is greater than x minus 1 squared minus 2. All right, and so let's start with this first inequality here. I'm going to remind myself that when I graph this one, to make it solid, because we have less than or equal to. And the associated equation is x minus 1 squared plus y plus 2 squared equals 9, right? Again, that follows the standard form of the equation of a circle, right? The center, remember, it's always x minus h squared plus y minus k squared, so my center is the point 1, negative 2. And our r squared is always sitting on the right-hand side, and the number that I squared to get 9 is 3. So I have a circle with the center at the point 1, negative 2, with a radius of 3. So I'm going to start with my center, go to the right 1 and down 2, plot that point. That's our center of our circle. And then I'm going to go to the right 3 from the center, up 3 from the center, left 3 from the center, and down 3 units from the center. And those are 4 points that our circle passes through. Okay. And again, it had to be solid, so I'm good to go there. Okay. And now I'm going to choose a test point. With your test point, you can choose any point that the circle doesn't pass through. All right. Here, now I can look at that graph and pretty much tell that 0, 0 is not going to be a point on that graph. But for me to make complete sure, I'm not going to use 0, 0. Whenever I use circles, I know it's you can use 0, 0 here, but sometimes it's a little hard to see because you're not able to draw a perfect circle. It's very hard to do so without using tools. And so what I do when I have circles is I use the center, because your graph of a circle would never pass through the center of the circle, right? By the definition of a circle. And so I'm going to plug in 1 for x and negative 2 for y. And so I get to get 1 minus 1 squared into the original inequality. Negative 2 plus 2 squared less than or equal to 9. And I want to see if this is going to be true or false. Well, if you notice, get 0 on everything when you plug in your center, which is pretty nice. And so I get 0 is less than or equal to 9, which is true. 0 is definitely smaller than 9. And so I'm going to have to shade inside my circle. All of my solutions to this inequality lie inside of that circle. And now I'm going to go to the other inequality, which we hadn't talked about yet, which is y is greater than x minus 1 quantity squared minus 2. All right, this graph is going to be dashed. Okay, the associated equation is y equals x minus 1 squared minus 2. And that's a parabola with this vertex at the point 1, negative 2. If you want to think about it in terms of transformations, you shift the parabola to the right 1 unit and down 2 units, and that'll be your graph. And so this one has its vertex that's at the center of the circle. And of course, with parabolas, we know that if they don't have a vertical stretch or anything like that, they're going to go through points like that. And I'm just going to sketch the graph of a dashed parabola that passes through those points. Okay? And now it's going to be time for me to choose some test points. All right? So I'm going to choose a test point, and this time I'm going to use the point, let's say I use the point 1, 0. I know that it passes through the point 1, negative 2, and since it is a function, there will be no other points on that graph that's going to have an x-coordinate of 1. And so I'm just choosing the point, for instance, 1, 0, okay, which is inside the parabola right there. All right, so I've chosen this point right here. All right, and so I'm going to plug in 1 for x and 0 for y, see if I get a true statement or not. And the second inequality, which is here, and so that'll be a 0 is greater than a 1 minus 1 squared minus 2. I get 0 is greater than negative 2, which is definitely true. 0 is bigger than every single negative number. And since that is true, that means I would have to shade inside of our parabola here. Okay? And so my solution set has to be inside of the parabola and inside of the circle. And the only place or regions where that happens is at these points that are in the middle. So these points right here. And so my solution set will only include that region right there. All right? And so those are all the points that I can plug into both of these inequalities and satisfy them both at the same time. All right? And this concludes our video on the systems of inequalities.